Hello everyone, this is the video lecture for Calculus 1, Section 2.3, Limit Laws. And we had a technical error. I was doing this, I did the whole first problem here, and then it just blew up on me. So I'm going to not redo all of this. What I'm going to do is just explain it from the beginning. I'm just not going to redraw it all, okay? So the main thing is normally I do a little lecture thingy before we actually get into every section. This time, there's nothing really to talk about, so let's just get started on some problems. So 23001, they say the limit as x goes to 2 of f of x is equal to 1. The limit as x goes to 2 of g of x is negative 4, and the limit as x approaches 2 of h of x is 0. And so they say, given all this stuff, part A, what is the limit as x approaches 2 of f of x plus 2 times g of x? Well, what I said is, hey, we got f of x, that's a 1, plus 2 times. We have a g of x. G is a negative 4. I mean, so all I'm doing here is plugging these in. And so I got negative 8 plus 1 is negative 7. Yay! All right, the next one. It says the limit as x approaches 2 of g of x cubed. Well, here's my g. It's negative 4. So negative 4 cubed is negative 64. Yep, that's right. And then part C says, find the limit as x approaches 2 of 4 times f of x over g of x. So I got 4 times 1 divided by g is a negative 4. And they cancel and make a negative 1. And there was another one that I have on my notes, but it's just not worth your time. So it's just that easy. Plug them in. You're done. And now we can actually do the second problem. And hopefully this time it doesn't all blow up on me. So I have these graphs, and they're going to be very particular, but the problem is that I'm not going to get them accurate enough for your viewing pleasure, let's just say. So this is going to be very crude, and I'm going to do the very best I can, but it's still not going to be good enough. I'm just going to say that right now. So we have this one here, and this is my f of x. And then the other one I have does something kind of like this. And then we have a circle, and it comes up. It's a solid, and then it goes down. I guess there's a solid over there too. There's a lot going on here, and this is my g of x. So I won't give you all the particulars because it's going to be just, it's not worth it. What I want to do is I'll give you the particulars that we need. So part A says find the limit as x goes to 2 of f of x plus g of x. And so what I'm really doing here is I'm applying this limit to each of these individually. So I basically just need to find the limit of f and find the limit of g, and then I'm just going to add them up and call it a day. So 2 is the key answer here, and you can see x equals 2 is right there. On this other one, x equals 2 is going to be this guy right here. So let me use a different color for a second. I'm really focused about what's going on here and right here. Notice that the limit means that I'm approaching from both sides, and they are both approaching the same coordinate point, I guess the same y value. And so what is this y value here? That one ends up being a negative 1, and this y value here is a 2. And so I have negative 1 plus 2, and yeah, that's a 1. And that is literally all we had to do. It's very simple to do these problems. The limit as x goes to negative 1 of f of x times g of x. Okay, so notice this time it's negative 1. So this is x equals negative 1 right here and right here. And I believe that it's a 2 height for this guy, but this one here is a 1 height, okay? And so I have a 1 height times a 2 height. 1 times 2 is 2. Wow, really? Yep. And then another one, the limit is x approaches 2 of x squared times f of x. And so I need to apply this limit to both of these pieces, I guess you can say. So my at 2, I'm going to be trying to hit up this negative 1 height. Again, the limit on both sides going to the same point. I know it was an open circle. I know that. That's not my point here. For lack of a better term, the understanding is that they're approaching the same y value. and that's going to be negative 1. So then this guy's definitely a negative 1. But what about this guy? Well, x is going to 2, so I'm going to make that a 2, so 2 squared. And so you can see 4 times negative 1 is a negative 4, and that's it, and you're done. That was all it was. Okay, next one. 23007. And so I've got the limit 8 of 2 plus the cube root of x, and then times 3 minus 5x squared plus x cubed. Make that look a little bit better. Okay. So what do we do here? Well, is 8. You're going to plug an 8 in, and you're going to call it a day. And I didn't even do any math. I just went to the calculator and plugged in 8, and I got 780. That was it. I got the limit as x goes to 6 of x squared minus 10x plus 24, all divided by x minus 6. Can I do the same thing as last time? Can I just plug a 6 in everywhere and it'll be okay? No. Notice that if you plug a 6 in right here, 6 minus 6 is 0, you would be dividing by 0, and that's not going to work. And that's also not the answer. The answer is not undefined or something like that, or D and E. And so I actually do have an answer for this, but it's not an error. So how do we go around doing this? There is actually a problem in the last section that we did something similar to this. And what I did was I factored the top. And so what I want to do is I'm going to factor the top. And what I'm guessing the top is factorable to make that x minus 6 go away. That's just my guess. I'm going to do that basically. But what's the other term here to make that work? So what two numbers multiply to make a 24? Well, 6 and 4. And then what two numbers add up to make a 10? Well, 6 and 4. And so this will be an x minus the 4. Two negatives multiply to make a positive 24. So that's confirmed. Now I cancel it. I'm trying to be official here. This is now what we're looking at. Well, there's nothing wrong with plugging it in now. So 6 minus 4 is 2. And that's it. That's your answer. So we are actually always going to plug it in at some point. It's just not always initially. We might have to cancel or simplify something before we can plug it in safely. And here's a good example of that. So I've got the limit as h, that's a little h, approaches 0 of the square root of 4 plus h minus 2 all over h. Okay. So, how do we do this problem? Well, what if I went back to the last section? The last section was promoting me using decimal numbers that were really close. So I'm going to say, like, method number 1, let's just say that h is equal to a really small number because going towards 0, 0, 0, 0, 0, 1. Okay, I'm just doing that right there. So I'm setting it equal to this, and then I'm going to plug that in and see what I get. See, if I plugged in a 0, just to let you know, if I plug in a 0, it's going to blow up. We don't want that to happen immediately. So we do want to plug something in, but what if I just plug in something that's really, really, really close? So I'm going to use a calculator, obviously. I'm not going to, go over this too much. And I got 0.2499999. Can you guess what the answer is going to be? 0.25 or 1/4. That's your answer. And we're done. That's the entirety of this problem. There's nothing else to do. Next question, moving on. But if I left it like that, I wouldn't feel like a good teacher. So what I want to do right now is I want to do it the long method, but I want to show you why, because later on it's going to be important to know these kind of particularities. So I'm not going to do this method. I'm going to do the long method, but the good, correct method to doing this. And it doesn't involve that. What I want to do is start with what we have. And the trick, because there's always a trick with this, is that I'm going to multiply by the conjugate of the numerator. And it's not necessarily just the numerator, but it's the one with the square root business. So the conjugate, again, means I had a minus sign. Now it's going to be a plus sign there. So the bottom is going to be really big, but the idea is that the top is going to multiply and cancel. So square root times the square root, I'm foiling here, by the way. Square root times the square root is actually itself. It becomes a 1 power. But we don't have to write the 1 power. I have a square root times a 2. So 2 square root. And then I got a negative 2 times a square root. You can see what's going to happen there. And then I got a negative 2 times a positive 2 makes a negative 4. And don't really do anything with the bottom right now. We'll deal with the bottom here later, okay? So just kind of leave it alone. Well, these guys cancel, obviously, and if you look right here, you don't really need those parentheses. In fact, if I erase them, I can kind of see something a little bit clearer. Notice we have a positive 4 and we have a negative 4. Those will also cancel, leaving me behind with something that looks like this. Okay. So, the H's now cancel. That leaves a 1 at the top. Let me write it over here. I'm trying to do this limit thing each time so that it's good and correct. I would say in class a lot of times I probably just skip doing all that. But I'm wanting to show you the correct way, and then we can shorthand it later, okay? All right. Now, eventually and always, we're going to plug it in. That's ultimately what this limit needs. It needs you to plug it in. So I'm going to plug in a 0 now. Remember, I couldn't do that at first because if I plug in a 0 here, it'll blow up. I'll get divided by 0, and that's no good. I think technically, if you plug in a 0 in the top also, you would get a 0. And 0 over 0 is kind of like a mystery. Those are supposed to be question marks. It's a mystery. Like, what does that really mean? We're going to learn more about this later. Right now, we haven't even taken derivatives yet, so we're not going down that path. Instead, what I just want to say is, if you're getting 0 in the bottom, at least, there's a problem. Let's see if we can cancel something. So we're going to plug it in now that we simplified, and now that we canceled stuff, and I got 4 plus 0, and then plus the 2. Square root of 4 plus the 2. That's 2 plus 2 is 1/4. And yes, that's the answer there, is 1/4 that we got, I don't know, 5-10 minutes ago. So could you just plug into 0.001? Wouldn't that be good enough? Yes. You're waiting for any other statement, right? But, yeah, I know there's a but. Let me do the but later. Let me show you what that would look like later, okay? So right now, can I just plug in a 0.001? Yes. Okay. Don't leave it, don't just think that we're done with that. We're not finalized on that. We'll get back to it. All right, so this next problem is a little bit more easy. I got 6x is less than or equal to g, which is less than or equal to, and they go 3x to the 4th minus 3x squared plus 6. And they say, what's the limit as x approaches 1 of g of x? I know this is kind of weird. What's going on is they're trying to sandwich this value in on both sides. They're saying that x is equal to 1, okay? So why don't I just plug in an x equals 1? I mean, again, the limit always means you're plugging it in eventually. Do you see any problems? Like if I plug in a 1, am I going to get divided by 0? No. If I plug a 1 in over here, am I going to get like a square root of a negative number? No. So everything's fine. Just plug a 1 in and see what happens. And you can kind of guess what's going to happen here. Well, 6 times 1 is 6. And if you plug a 1 in all right here, you'll get 3 minus 3. Those cancel. Leave a 6 alone, so you got 6. So I got 6 on this side, you got 6 on that side, and I'm saying my g is in between them. I'm sandwiching it in. Well, what's the only number that g could be between 6 and 6? Well, it's 6. That's it. It's very simple. No big deal. All right. So 23018. I got a limit as x approaches negative 1 of 6x plus 6 all divided by the x plus 1. And so here's an interesting thing here. Could I plug in something that's really close to -1? So could I say a negative 0.99999? Or could I plug in a negative 0.1 or negative 1.00001? Yeah, but in fact, it wouldn't come out like you're thinking. And I'm not gonna do that right now because I want to show you how simplifying is a better method. But what you're gonna find is not what you're looking for. Okay, so let's try to simplify this like straight. It's silly, but it should still work. What if I factor a 6 out? Oops. Okay. And I have it like this. Well, like simple math in my mind is that we got x plus 1 and x could just do here is cancel those guys and now we just get a 6, right? Yeah, kinda. So how am I supposed to, I don't know, deal with that? It's not really 6. This is answer 6 is not the answer. So how do I fix this? Well, you don't do that. What I do want to do is end up plugging these numbers in eventually anyways, okay? I know that sounds kind of crude, like I said, hey, don't do it, and then all of a sudden I'm doing it. Well, I tried this method. I tried putting a 6 into WebAssign, and it's not accepting it. And so now I want to go down this road and show you why that's not going to happen, okay? So I'm going to plug in the two numbers, or at least something close to those. They don't have to be exactly the same. Plus 1. Okay, and what I got whenever I plug this into the calculator, I got a negative 6. Okay, so now I'm going to plug in this guy here. Just kind of going through it. 999 plus the 1. And when I did this one, I got a positive 6. Okay, so did I get a 6 as my answer? Yeah, but I got a negative, and I also got a positive. And, well, here's my point. What's the limit? Just like we've seen before, if the limit over here and here are different values, right? We've seen this before. If you're coming in and you're approaching it from this side and you're getting a positive 6 and you're getting a negative 6, we have a problem because those don't work. They're not the same. So your actual answer here is D and E, actually. I know that it looked good to cancel and simplify, and a lot of times that might have worked, but because the absolute value, the negatives don't allow for that. I guess what I'm trying to get at with all of this is that it's important to know both methods, the canceling, simplifying stuff, which I'll also show you another time in just a second, and also this kind of crude but working method that sometimes just, you got to do it. Okay, multiple methods, learn them both, and that's okay. Both are okay. G of x is equal to, and then we got a big curly here, so this is a piecewise, x, as long as x is less than 1. I got 4 whenever x is equal to 1. I've got 2 minus x squared when x is between 1 and 2. And then I got x minus 3 whenever x is greater than 2. Okay. Part A says find the limit as x goes to 1 from the left side. Do you remember that? This is from the left side. So I'm wanting to get close to 1, and I would say, oh, it's 4, right? Because it's equal to 1, it's at 4. Well, hold on. What's really going on here is that we have this function, and we got a solid point, and then we got another function. They're actually going to be the same height here in a second. And I think I messed up. Technically, it looks something kind of like this with a point up here. And so I want to know, as I'm approaching from the left and only the left, from the left and only the left, numbers less than 1, like I got 1 on my number line. So what's on the left side over here? Well, I don't know, 0. I don't know, 6.5, right? So we're looking for numbers that are smaller than 1. And notice that the piecewise says less than 1, and so I'm going to use this as my function. And always with limits, as I've always said it, eventually you're just going to plug it in. And so you're going to plug in the 1, and so basically you just got, well, 1. There's nothing else to do. It's almost too easy. So don't overthink it. I'm just saying this is the one that we need to look at. This is where we're going to plug in a 1. And you plug in a 1, what do you get? You get 1. Okay. I know, it's almost too easy. So just don't overthink it, please. I'm trying not to make it confusing, I guess. So the next one says, hey, what's the limit as x approaches 1? Not from the right, not from the left. They're looking for both sides. And so we already did this one. Again, this point does not matter to me. I don't care about the point. I want to know, hey, when is it going to be greater than 1? And so we're going to be using this guy as well. So I'm going to plug in a 1 here. I'm going to plug a 1 in there. Well, we already did it. So I'm going to plug a 1 in to this guy here. Well, 2 minus 1 is 1. So I got a 1 on the right side. I got a 1 on the left side. So what's the answer for both? I got 1 on the left, 1 on the right. What's the answer for both? It's 1. Cool. Well, I guess I already skipped ahead a little bit. It says, hey, what's the limit on the right side? So this is the right side. Well, we just did it. It's that one right there. And then finally they say, okay, well, yeah, what's the actual point, though? Let me try to spell point. What's the actual point? Well, that's the thing I crossed through. It's 4. That's it. 4. I know that we're not doing limits here. I just want to know, hey, we got a graph. Where's the solid dot at this vertical line right here? Where's the solid dot? It's right there. Okay. Cool. I don't make these problems up. I actually really don't like piecewise functions, but that's just between you and me and everyone listening, apparently. So I have limit as x approaches -6 on the right of this weird boxy x thing is equal to what? So those are 2 little lines on a boxy thing. This is actually the greatest integer function. Greatest integer function. And I'm so sorry that they're using negatives to demonstrate how to use this properly. It's really sad. We should be thinking positives and stuff. So here's how greatest integer works. You got a solid, you got a line, and then you got a circle. A solid, a line, and then a circle. A solid, a line, and a circle. And you keep doing that all the way up. It's called a step function because it looks like steps. But if you're going to go in reverse, there's a circle, and then a line, and then a solid here. And so at every integer, this is 1, this is 2, this is 3, this over here is -1, we have this step. So if you're thinking about greatest integer, I'm saying, like, if you have the greatest, what's the greatest integer for, I'm just going to make something up here, 1.2. Well, the answer is just 1. It basically is just saying, hey, what's the integer here? And it's just 1. Cut off the decimal. That's really what's going on. Cut off the decimal. Okay, so what about 2.7? And you're thinking, oh, well, it rounds up to 3. I didn't ask you to round. I said cut off the decimal. Boom. Okay. It gets a little weird whenever you're using negative numbers. So like -6.5, what's going on there? What's actually going to happen is it's a -7. I know, and that's why this negative stuff right here is just not cool to demonstrate all this so early. But why does this happen? Well, if you're looking right negative side of things, it's basically, I don't want to say it's reversed. It's just we think of it differently on the number line of side of things, okay? So let's just say that right here is -6. And so -6.5 is going to be right here. But what would this height here be, and what's that height right there? This is a -7 height, and that's a -6 height. If you actually continue it down with the steps, you would kind of see that. That's just the best thing I could say is look kind of at the graph. You can see that each one of these right here is at like 1, 1, 2, 2, 3, 3. So -6, -6, same thing as always. But if you're wanting to go a little bit on the left side, you're over here now, okay? We're going to use that concept here in just a second. But let's actually apply what's going on here. It says we're going to -6. So I'll just use this right here as my like -6 area right here. And they want to go on the right side of it. And so on the right side, again, of this blue line, we got a left side, we got a right side. So we're on the right side. I'm following. What would be the height as I keep going this way? Well, yeah, it's going to be -6. So that was pretty easy there. Part B is the limit as x approaches -6, like at all. Again, this is being both sides. And if you look here, we got a solid, we got a circle. Doesn't really matter. They're totally different places, different y values. So this is a DNE because they're not the same. For part C, we have the limit as x approaches -6 from the, -6.1. Again, we've already done this one. I just talked about it up here with all this. It would be a -7, and there you go. All right. I actually only have one more problem left in this section, but it's a big one. And this is, I would say, the best problem. It's the more, hey, look forward to these kind of things. Because it's a pretty big one, okay? So limit as x approaches -2 of 3x squared plus ax plus a plus 9. I know that's going to look really weird there. Divided by x squared plus x minus 2. And they say that this will actually end up being a limit, but I need to know what is a equal to, and then what is this L equal to? Okay, so I need to solve for a to make this limit work, and then I'm asking, what is that limit? They're really leaving us in the dark here. And that's why this is one of the harder problems. That's actually why I want to do it with you, because, well, it's confusing. How I approached it is I said, you know what, these guys are actually tied together. And I actually wrote that in my notes. I said, these guys are together. And I'll demonstrate why here in a bit. But on the surface level, this is just a number, this is a number. So they're both just numbers, I guess you can say. There's no x's attached to those. All right. We'll get back to that in a second. The bottom, if I could factor the bottom, I might be able to find a way to kind of simplify something or other. I don't really know. So if you look at the bottom and factor it, you actually get x plus 2 and x minus 1. So what two numbers multiply to -2 but add up to a 1, and there you go. We got them. So why is this limit as x goes to -2? Why is this a problem at all? If you plug a -2 in right here, you get -2 plus 2. That would make a 0. And so essentially you'd have a divide by 0 again, and that doesn't work. Even a 0 over 0, it's still not working yet. We can't have any of this work. So our problem is actually right here. This is our problem, okay? What we want to do is we want to cancel it. We want to cancel this out. If we can cancel that guy out, then everything will be super easy and it will work, okay? So now, back to the top. I want this top to be factored down, and very particularly to an x plus 2, okay? I want this top to be factored in particular with an x plus 2. That way, I would have this is my top and that's my bottom, and I would eventually just cancel those. That's the reason why I want to do it. But if you're looking here at the top and I'm saying factor that, that does not make sense. It's all weird and doesn't look right, especially with this 3 in the front. That doesn't help. And so if I'm assuming, I'm going to put that right here, I'm assuming that we're going to have this 3 has to come from somewhere. And so it's actually a 3x plus something else, okay? All right, so let's just kind of, let's zoom out here, and I'm gonna learn how to get this guy here in a second. I'm saying that 3x squared plus the ax plus, and again, a plus 9, I want to keep all together. this should factor down, should factor down to this right here, and I need to figure out how to get that other thing there. Okay, and I mean, if you've gotten this far, that's already a lot, okay? Because this is just, it's a crazy big problem. But I'm trying to show that necessarily that 3 has to come from something, and this is what we're doing to get it. So what is this over here? I'm going to actually call this B, like a capital B, and I'm going to solve for B. I'm just using B because there's an A right there. You can use an X, or, well, you can't use X. You can use a Y. But I'm using capital B so I can kind of understand what's going on here. With all this. Now, how to be able to do this, I'm actually going to go in reverse. I'm going to FOIL this one out, and they should, again, should be the same, okay? So I got x times 3x is 3x squared. I got x times the b is a bx. I got 2 times 3x is the 6x, and then 2 times b is 2b, okay? And this, again, should be equal to this stuff. Now, notice that we got my x's, these guys are together, got my number of numbers, those guys are together, and so I have 3x squared is equal to 3x squared. Those check out. But what about everything else? And so over here we got our x's and our x's. So I got little a x should be equal to bx plus 6x. And you don't need all those x's, so you got a is equal to b plus 6. And you can solve for A and B if you need it, but let's just hold on to that for a second. Let's go with the second one. So what about these numbers? So I got A plus 9 is equal to, and on this side here we got 2B. All right. Again, I don't really know how I'm going to use it, but I got this thing, and I got this thing, and what you're looking at is actually a system of equations. Yep. So remember doing all those matrices back in college algebra? Yep, and that's what we're seeing here all over again. You thought you'd never see those again. What I'm going to do is actually, I'm going to take this A, and I'm going to plug it in right here. I'm not going to go down those matrix method. That's way too long. But I do want to plug that in, substitute it, I guess, and start to solve. So we got B plus 15 is equal to 2B. I want to minus a B on both sides. And so we actually end up with a B is equal to 15. Now, B was not what I was looking for. I wanted A, so let's do this right here. And so I got A is equal to B plus 6. Well, I know what B is equal to. It's 15 plus 6 is 21. So A is equal to 21. That's actually one of my answers. And if I go back now, I got the limit, -2 of the 3x squared plus ax plus a plus 9 all over x squared plus x minus 2. This is still a limit that I need to figure out. Well, if I plug in the 21, what I'm going to get is 3x squared plus 21x, and then 9 and 21 makes a 30. And then in the bottom, well, that doesn't really change. I can factor both the top and the bottom. I think I can factor out a 3 from the top here. Yeah, I did it a little differently because if you go back, I already know that it's going to look like this. And we already have a B, and B is 15. So I could just factor that down immediately. And we already have the factors here. So we don't have to actually spend a lot of time actually factoring this down. I already know that it's going to do this. And then B was 15. And then in the bottom, I had an x plus 2 and an x minus 1. So I already kind of knew that. So I canceled those guys, which I eventually thought I would do anyways. And now I'm left with this more simple expression. I could plug in a -2 plus the 15. And then I got a -2 minus the 1. So -6 plus the 15. Down at the bottom is a -3. Do the math, and I get -3 as my final answer for that limit. Whew. And we're done with that section now. So I want to note one thing. Notice that we still have this limit as x approaches -2, but I kind of left it off right here. I just didn't. I'm shorthanding it I'm just, you don't have to fill it back in later or nothing. Oops. Well, I'm not. If you're going to fill it in, do it correctly. But you don't have to always have that. I mean, nothing's changing here. Just, heck, you don't even have to write the limit, really. Oh, I didn't just say that, did I? So, at least write a limit so you remember to go and apply it at the end. But it's okay to shorthand some of this stuff so that it's easier on your hands. So, that's all I got. So, thank you very much, and have a great